Oh, he gone. Oh, crib call. Touchdown. Oh, I didn't see you there. I'm Cadet Caden Yeomans in C4. Go Cowboys.
I'm Cadet Mariana Starita. I'm with I4. Go Beams.
Shoot. Best of three?
All right, best of three.
Oof. That clap. I'm Christopher Wisman, Company C1.
I'm Vibu Shah, Company G1.
I'm part of Captain Cassidy's E1 hour.
Baseball had me take the ACFT last weekend. I was cooked.
Bro, I'm telling you, mine was so cooked during Beast. Like, I think it's because we weren't sleeping good. I wonder why that is.
This led us to our research question. How does sleep affect a cadet's ACFT score? We're going to be measuring this by using our independent variable, which is the hours of sleep a cadet gets, and our dependent variable, which is the score the cadet receives on the ACFT.
All right, to set up our experiment, we're going to go and we're going to take 16 cadets from all the companies, Alpha through India, taking 4 from each. So 4 from A1, 4 from A2, 4 from A3, 4 from A4. And we're going to choose that by random selection. So we're going to take the pools of each individual company, and we're going to choose random 4 cadets to represent in our experiment.
For our experiment, we're going to have each of the individual cadets wear a watch that is going to monitor how many hours of sleep they're getting. So the operational definition for our independent variable of sleep is going to be how many hours are recorded on that watch. And then for our dependent variable, the ACFT score that the cadet gets, we're going to have an operational definition of the composite score out of 600 that they get on the ACFT. So for our control group, we're going to have the individual cadets take an ACFT after getting 7 hours of sleep, which is within the recommended amount of time for an individual. And then for our experimental groups, we're going to have cadets take an ACFT at 4 hours of sleep and then at 10 hours of sleep to see how those affect their base ACFT scores.
So you may be wondering, why is random sampling the best method? So there's this thing called voluntary bias, where an individual who's particularly good at something may volunteer themselves for like a certain study. So for example, we have this cadet here, Cadet Private Caden. I don't know who that is. He's very, very strong and gets very high ACFT scores. So he may want to volunteer himself for this study because he wants to flex a little bit. But that's bias. Or we have Cadet Chris, Cadet Private Chris. He's over here. Say hi.
What's up?
Who's not as big and strong as Caden and may not want to volunteer himself for the study. So that is why we do random sampling, because we can get people from all different backgrounds randomly.
So, you may be wondering, why are we waking these cadets up so early? Well, we've accounted for that. If they're taking an ACFT after 4 hours of sleep, after 7 hours of sleep, and after 10 hours of sleep, we don't want these to be in consecutive days, let alone consecutive weekends. Thus, we're going to have them take an ACFT once every 2 weeks. We'll have them take it on a Saturday morning so that they have plenty of time throughout the rest of the weekend to recover. For example, we'll have one of them take 4 hours of sleep Friday into Saturday, and then 2 weekends later, they'll have 8 hours of sleep Friday into Saturday, and then 2 weekends after that, 10 hours of sleep Friday into Saturday, and they'll have an ACFT every Saturday morning.
Breaking news!
In order to start our experiment, we're going to be assuming that our null hypothesis is true.
What's a null hypothesis?
A null hypothesis is when you assume that your dependent and your independent variables are completely unrelated. So the case of our experiment, it would be that sleep and ACFT scores on cadets are not related.
Okay, yeah, that makes sense.
Now, if we want to prove something, we need to have an alternate hypothesis. So the case of our experiment is that we're going to try and prove that sleep actually does have an effect on cadets' ACFT performance.
Okay, how do we know that we proved our alternative hypothesis true though?
That goes into our p-value.
Oh wait, I know what that is. Okay, so in our experiment, I think we have to have a p-value of less than 0.05%, right?
Yep.
Because that's the chances of our results occurring randomly, like completely by chance.
I thought I'd vlog to finish off the video, but my group has a question for you guys.
Do you have any questions?
If not, go Army,
Beat Navy!
go Blue.